Welcome to this video on mathematical expressions and order of operations. Let's jump straight into it. So for order of operations, you are probably been introduced to PEMDAS, which says that you should do parentheses first, then exponents, multiplication, division, addition, and subtraction. Now what does this mean? Let's do an example and see. Say you have 2 plus 2. Everyone knows how to do this and it's pretty straightforward. Equals 4. Now let's add to this. Say 2 plus 2 times 3. How do you do it? You do 2 times 3 first. So you have 2 plus 6 equaling 8. Because multiplication was before addition in the order of operations. But here's what's a bit confusing. So if you do 2 plus 2 times 3 minus 4, is it now allowed to do 2 minus 4 before you do 2 times 3, or do you have to do 2 times 3 first because it is multiplication before addition? But take a moment to think for yourself. So in this case, you're actually allowed to do 2 minus 4 first, or you can do 2 times 3. So let's do it first. 2 minus 4, negative 2, plus 2 times 3. Negative 2 plus 6 is equal to 4. It is perfectly fine to add terms. These are terms, even though you do have multiplication appearing. What's not allowed is this. 2 plus 2 times 3, negative 4. You may not add this 2 with this number or this number. You can only add whole terms. So if you take a look at this expression, this is one term, this is another term, and this is a third term. Note that this is a plus. We don't typically write the plus when it comes the first position. So you may only add whole terms. That's why you have to do this multiplication before this term can be added to any of the other ones. Let's do another example. Let's identify the terms first. This is a term. This is 1. Here's 1. This is 1. And this is 1. Notice how the multiplication identifies that this is a group. This whole thing here is a group, not as a term, as is this one. And the sign follows this term, this sign follows this term, and so forth. How do we do it? Let's add the plus 3 and negative 3 first. I'll move it to the start just to make it more clear. 3 minus 3, and then plus 1. Let's move also that to the start. You can shift them around any way you want. It doesn't matter. And then leave these others as they are. Negative 6 times 2 times 3 plus 4 times 2. Plus 3 minus 3, 0. 1. I omit the plus because it's first. If I were to write this at the end, I will write the plus. Minus 6 times 2, let's do that first. So that's negative 12, this n times 3. We haven't included the 3 yet, so we just add it like this, multiplied by 3. Since this is 6.2. Plus 4 times 2 plus 8. Now I may add 1 and 8 if I wanted to. Let's do that. So minus 12 times 3 plus 9. 8 and 1. Now we'll do this one. 12 times 3, 36, negative 36, plus 9, negative 27. This applies equally much inside a parentheses. Let's see. 4 plus 2 plus, and then a parentheses, 3 times 2 plus 4, like this. 4.4 plus 2, let's do that first, that's 6. Plus, inside here, the rules are exactly the same as everywhere else. But observe the parentheses. In this case, the parentheses doesn't have any effect, but there are many cases which the parentheses have an important effect, and we'll come to those later. But for now, let's just solve it inside the parentheses first. So 6 plus 4, 6 plus, this is 10. Now we'll remove the parentheses, which is 16. Let's see when we cannot remove the parentheses as easily as we did right now. That happens 3 times. There's 3 rules, depending how we look at it. So if you have parentheses, there's something inside here, doesn't matter what it is. If there's a negative symbol here, or there's a number, or there's a number underneath like a fraction. If any of those 3 or several of them happen, then you need to think, how do we then open the parentheses? Let's do an example. Negative 1 plus 2. Sure, you can do negative, calculate the inside, 3 is equal to negative 3. But you can also do it this way. Open the parentheses without doing the calculation inside. So this negative sign here means that any sign which is inside the parentheses will be flipped. Mark there's a hidden plus here. We don't typically write plus signs when they're at the start, and a parentheses signals a new kind of start. So negative 1, this is flipped because this, so negative 2, negative 1, negative 2, negative 3. The same thing we got up here. Let's see the other rules. 4, 3 plus 2. Again, you could do 4, 5 is equal to 20. But you can also do 4 times 3, 12, plus 4 times 2, 8, 12 plus 8, 20. Same thing. Now let's do a combination. Negative 2, 1 minus 2. Negative 2 times plus 1 is negative 2. Negative 2 times negative 2 is plus, because those 2 minuses become a plus, plus 4. Plus 2. Just like if we did negative 2 plus 1 minus 2 minus 1, negative 2 times negative 1 is equal to plus 2. Again, same thing. Let's do a fraction. This is a little bit more complicated, but the same rules apply just the same. First, I'll add this term with the entirety of this term. So 2, let's write 3 times 1. This is equal to 3. So we do 2 plus 3, not this individual 3, but the whole term equals 3. 2 plus 3, 5. Now we do negative 2/3. We'll open the parentheses now, so negative 2/3 times 27. Negative 2/3 times negative 9. Two negatives becomes plus 2/3 times 9. Negative 2/3 plus, then we get a negative. This one switches, remember, switches this one to become a negative, switches this one to become positive, and this one to become negative. So 2/3 times 2 times 3. This 3 can be divided by this one. You can imagine in your head that this kind of shifts away over here. So when we're talking about fractions like this, they're bound here by multiplication. There's no plus or anything inside here. You could have, I'll show you that later, but here this 3 can actually move about here. And so we can kind of imagine that we write it here instead. And 3 divided by 3 is 1. So let's see. 27 divided by 3, that's 9. Write this 5 first. 27 divided by 3, that's 9. This 2 has not been doing anything yet, so 2 times 9. Plus 9 divided by 3, that's 3 times 2. 3 times 2. This here was 3. These are gone, so we're left with negative 2 times 2, negative 4. Five, negative 18, plus 6, minus 4. 5 plus 6, 11, minus 4, that's 7. 7 minus 18, negative 11. Okay, let's see now another example. Suppose you have 2, so negative 2 times 3 times 4. This whole thing here is a term. And you have to evaluate what this whole term is before you can add it with any other adjacent terms. These ones are complete. They're only one number with a adjoining sign and can be added together. But you may not add an individual one of these with these because you have to evaluate the whole term first. How do you do it? Well, we've seen a few examples now. Let's see a common misconception. So you have negative 2 times negative 3 times 4. This is a new example. Here we have also a negative 1, which appears inside among the other factors. This is a term. This whole thing is a term, and this is a term. This negative does not mark the start of yet another term. It only signifies that this 3 is negative, And the parentheses, you can imagine, kind of protects this whole thing and marks it as one thing, one item. So let's do -2 times -3, that's +6. We might as well put on a parentheses. It's customary not to write the plus, but it isn't wrong to do so either. But if you're gonna do it, you should better add some parentheses around here. Oftentimes it's a good idea to add more parentheses than too few. Times 4. This 2, this is only an example, so let's include those as well. But those add to 0. -2 + 2. 6 times 4, 24. Again, a positive number, a hidden plus. I could write it, but it's customary not to do so. 24 is the answer. Let's do one last example. This 2 divided by this 2 becomes 1. Then we do what's known as canceling. We write a slash above this one and the one it's cancelled against. You made it on the cross diagonally like this, but only when you have multiplication that binds them. You would still have multiplication here, even if this 2 was written in the middle, like we could do. We could write +3 times -2 times 4/2. This is exactly the same as this. I kind of just moved this 2 into the middle, rearranged it, but that is perfectly allowed to do so. So 2 divided by 2 is 1. 3 times 4, 12, and a negative sign. So -12 plus 8 times, and now not 8 times 2 only, but 2 times this whole term, which then becomes 8 times 2 times 3. Kind of joins them in outside the parentheses. Now we have plus 8, -4, so that's -32. -12, -32 becomes -44. Plus 8 times 2. Actually, let's do 8 times 3 first. 8 times 3, that's 24. And then we do multiply by 2. So I did those first, and then this. The order of how you multiply the factors in doesn't matter. -44 plus 24 times 2, that's 48, which adds up to 4. That's the final answer. Thank you for watching. In our next video, we'll have a look at algebra. That's calculation and working with similar forms of calculations with letters in them. Thank you.